Kia ora year 12 and 13. This is part 2 of question 4b from the 2013 paper. So this is kind of separate from part 1, which is an algebra problem. It's also about a thing called the relativistic rocket equation. But this time we're trying to show that something is the solution to a DE. Okay, so here's the question. The equation that we had in part 1 can be derived from this differential equation. Okay, and u and c are constants. So here it goes. We're told that dm by dv is equal to this. Right, so what have we got in here? Well, we've got the variables are m and v, and u and c are just constants. Right, so it says that, but it's always worth looking at what letters are things that can change and what letters are things that can't. Because one of the things with scholarship questions is often there won't be many numbers at all, just loads of different letters. Alright, and we're asked to show that this is a solution of this differential equation. So this comes under the differentiation topic in level 3, which is different from most of the DE stuff that you do, and you'll probably meet that in integration, okay, just because of how we divide up, how we teach things. What we have to do here is to figure out if we've got this equation, what is dm by dv? So we're going to work that out, and we're going to show that it turns out to be this thing here. So the first thing you notice is that we don't have m equals. We've got the log of m equals. What we're going to want to do is to use implicit differentiation. So there's your first clue. Okay, so we're going to try using implicit differentiation on that. The other thing we could do that I didn't do is we could do e to the power of both sides. Okay, but that's going to be a little bit messier. But if you really have a thing about hating implicit differentiation, I guess you could try that. Implicit is a really good efficient technique though. So pause the video now and try and use implicit differentiation to start the problem. Okay, so we've got log of m is equal to negative c over 2u times the log of all this. Right, so we look at this and we start doing implicit. Now implicit says I can't differentiate this with respect to v, but I can easily differentiate it with respect to m. And then I can use the chain rule. So that gives me a nice left-hand side that looks like that. Now I come to look at this right-hand side, and I say, okay, well, this is not too bad. I just want to differentiate it with respect to v. However, there is a bunch of simplifying stuff that we can do first before we go and differentiate this. You don't have to do that. You could use the quotient rule for this derivative here. You've got a v in the numerator and a v term in the denominator. It's nice to avoid the quotient rule wherever you can. So what I'm going to do is do some simplification before I get into my differentiation. Okay, so we're going to go back to here. Log of m is equal to negative c over 2u times the log of this thing here. Well, we can simplify the denominator by saying 1 plus v over c is the same as c plus v over c. We can simplify the denominator by doing something similar. So that's nice because now we've got a common term here. We can multiply top and bottom through by c. So we get the natural log of m is equal to this. So that already looks better than this thing back up here, but there's some more simplification that we can do using our log rules. Okay, so remember from level 2, the log of a over b is equal to the log of a minus the log of b. So we can apply that rule here. Now we've got the log of m is equal to negative c over 2u times the log of c plus v minus the log of c minus v. Finally, we're ready to do our differentiation, and we get this. 1 over m dm by dv is equal to negative c over 2u times 1 over c plus v. Right, so what am I doing here? I'm doing the chain rule on this. So the outside function is the natural log, and then the inside function is the c plus v. The derivative with respect to v of that bit is just 1. And similarly here, we're going to have minus 1 over c minus v. That's the outside function, the log. The derivative of c minus v with respect to v is going to be negative 1. So that gives us negative c over 2u times 1 over c plus v plus 1 over c minus v. Now it's time that we looked where we were going. Alright, whenever you're doing a proof or a show that or something like that, just make sure you keep in mind where you're trying to end up. And we want to end up showing that our derivative ends up being this. So, that gives us a clue for what would be a good thing to do next. And that's to get a common denominator here and then to start manipulating it into this form. So I'm going to do that on the next slide. If you're still watching, you might want to see if you can finish the problem off on your own from here, and then you can just quickly flip through the video to check you got it right. Okay, so 1 over m dm by dv is equal to negative c over 2u times, well, here we've got c plus v times c minus v, and in the numerator we've got c minus v plus c plus v. Alright, so I'm just cross multiplying as usual. That works out to be negative c over 2u times 2c, and here we've got c squared minus v squared, because this is just the difference of two squares. We can take out the common factor of 2, and now we've got negative c squared over u times c squared minus v squared, which is negative c squared over u. Just go back a bit. Right, I'm going to divide numerator and denominator by c squared. So we're going to have equals negative 1 over u. Let's look what happens here. C squared over c squared is 1 minus v squared over c squared. You can see we're very close to what we need to have, so just one last line to go. Okay, so we've got to here 1 over m times dm by dv is equal to negative 1 over u times that. You can just multiply both sides through by m. Finally we get dm by dv is equal to negative m over u 1 minus v squared over c squared as required.